Hello, I am Dr. Sigar Kanti, Associate Professor of Mathematics, Government First Grade College, KR from Bangalore. In this video, I will discuss some simple results in graph theory. Number one, with the usual notations, show that delta G less than or equal to 2Q by P less than or equal to capital delta G. Okay. So here delta G is the minimum degree of the graph G and capital delta G is the maximum degree. P is the number of vertices and Q is the number of edges of G. Okay. So here let me start. Let G be a PQ graph. G be a PQ graph. And we have the result sum of the degrees is equal to twice the number of edges. Okay. So therefore average degree is equal to sum of the degrees divided by number of vertices. And here this is the average degree of the vertex. Minimum degree is delta G, maximum degree is capital delta G. So therefore here we can write always the average degree is greater than or equal to small delta G and always it is less than or equal to the maximum degree capital delta G. Okay, this is the result. One more example. In a graph with 6 vertices in a graph G with 6 vertices, show that G or G bar contains a triangle, that is 3 mutually adjacent vertices. So that is, this is the triangle. Okay, G or G bar contains a triangle. This we have to prove. Okay. Now here I will consider a graph with 6 vertices. Let G be a graph with 6 vertices and G bar is its complement. So both G and G bar have the same number of vertices. Okay, and 2 vertices are adjacent in G, then they are not adjacent in G bar. Or suppose 2 vertices in G are not adjacent, then they are adjacent in G bar. That is, 2 vertices of G are adjacent if and only if they are not adjacent in G bar. So that means here let U be a vertex in G. If it is adjacent with V in G, then it is not adjacent with V in G bar. Okay, and any vertex U is adjacent with one vertex here in G, then it is adjacent with 4 vertices in G bar, because some of the G and G bar are complements to each other here. If a vertex is adjacent to some vertex in G, then it is not adjacent here. Or if it is not adjacent, then it is adjacent in G bar. Okay. So here let me take, let U be a vertex in G. Okay. So degree of a vertex U in G plus degree of the vertex U in G bar must be is equal to P minus 1, that is 6 minus 1, it is equal to 5. So that is here degree of U in G plus degree of U in G bar must be is equal to 6 minus 1, that is equal to 5. Now here U be adjacent with, or we write like this, degree of U in G is equal to 1, then degree of U in G bar is equal to how much? This plus this is equal to 5. If this is equal to 1, then degree of U in G bar must be equal to 4. Okay. So that is this is equal to 4. Suppose degree of U in G is equal to 2, then it is equal to 3 in G bar. Suppose degree of U in G is equal to 3, then it is equal to 2 in G bar. Suppose degree of U is 4, then here it is equal to 1. Suppose degree of U is equal to 5, then its degree is equal to, sorry, here this is 3, 4, 5. Okay. And this is equal to 0 because there are only 6 vertices. See here, we can observe degree of U is minimum 3. Okay, here it is 1. If it is 1 in G, then 4 in G bar. If it is 2 in G, then it is 3 in G bar. Okay, so here minimum 3, here it is exactly 3. And here, in this case, degree of U equal to 3 in G. In this case, degree of U equal to 4, that is minimum 3. Degree of U in G, it is minimum 3. So that means here, if you take any vertex U, then its degree in G or G bar is equal to 3, minimum 3. Okay, so here degree of U in G or G bar is at least 3, greater than or equal to 3. So let me consider this vertex U is in G. So here let degree of U in G is equal to 3, or we say that it is greater than or equal to 3. Then what this implies here, U is adjacent with at least 3 vertices, say V1, V2, V3 in G. Okay, so it is like this. I have taken U, a vertex in G we have taken. This is adjacent with at least 3 vertices V1, V2, V3. Okay. Now here, if any 2 vertices, of this out of these 3, V1, V2, V3 are adjacent. So that means here, suppose V2 is adjacent to V3, or V1 is adjacent to V2, or V1 is adjacent to V3. Suppose V2 is adjacent to V3, then U, V2, V3 is a triangle in G. If suppose V1 is adjacent with V2, then U, V1, V2 is a triangle in G. Or if V1, V3 are adjacent in G, then U, V1, V3 is a triangle in G. So that is here I will take, if any 2 vertices of V1, V2, V3 are adjacent in G, that is say V1 is adjacent with say V2, then U, V1, V2 is a triangle in G. Okay. Now if suppose no 2 vertices of V1, V2, V3 are adjacent in G, that is next, if no 2 vertices of V1, V2, V3 are adjacent in G, then these three vertices, these three vertices are mutually adjacent in G bar. Okay, if these three vertices are not adjacent in G, then they are adjacent in G bar. Okay, so that is here, that is G bar contains a triangle. That is here a graph with 6 vertices, either G contains a triangle or G bar contains a triangle. Next I will go to one more example. Show that any self-complementary graph has vertices of the form 4n or 4n plus 1. So that is, suppose G is a self-complementary graph, that is G is isomorphic to G bar. Then the number of vertices are of this form, that is multiple of 4 or multiple of 4 plus 1. So that means here maybe if G is a self-complementary graph, then number of vertices is equal to 4 or 5 or 8 or 9 or 12 or 13, like this. Okay, so here let me consider, let G be a self-complementary graph. So that is G is isomorphic to G bar. And here let Q be the edges of G and Q bar be the edges of G bar. Now, since G is isomorphic to G bar, implies that number of edges in G must be equal to number of edges in G bar. That is here Q is equal to Q bar. Okay, Q equal to Q bar. Now, sum of the edges, that is number of edges of G plus number of edges of G bar, must be equal to number of edges of the complete graph with p vertices. So here if G is a graph with p vertices, then number of edges of G plus number of edges of G bar must be is equal to the total number of edges in complete graph Kp. So that is here Q plus Q bar is equal to P into P minus 1 by 2. So this is the number of edges in complete graph with P vertices. Since Q bar equal to Q, this becomes Q plus Q, this is equal to 2Q. So that is 2Q is equal to P into P minus 1 by 2. Or we write Q is equal to P into P minus 1 divided by 4. Okay, so we have to prove that, and this is an integer here, this is a positive integer. Okay, Q is a positive integer. P into P minus 1 by 4, integer is equal to P into P minus 1 by 4. Now here I have to prove that P is of the form 4n or 4n plus 1. So here this P may be even or P may be odd. I will consider two cases here. If P is even, then I will show that this P equal to 4n or 4n plus 1. Okay, so here let P be even. So that is, say P equal to say 2 into M. But we have Q is equal to P into P minus 1 by 4. So that is here P is 2M into p minus 1, 2m minus 1 divided by 4. This is equal to 4m square minus 2m divided by 4. So this is to be an integer. What this implies here is 4 must divide 2 into m, because here this quantity is divisible by 4 and 4 is here. So 4 divide this quantity, no doubt. 4 must divide this quantity also. Therefore here this must be 4 into something. So that implies m must be 2 into something here. So that is here. This implies m is equal to something like this, 2 into n. So therefore we have taken p equal to 2 into m. This is equal to 2 into m is 2n. This is equal to 4 times n. So that is p equal to 4n. Now another case, let p be odd. P be odd. So that is here, let me take p is equal to 2m plus 1. Again I will go to this equation. Q is equal to p into p minus 1 by 4, or p into p minus 1 by 4 is equal to an integer. P into p minus 1 by 4 equal to a positive integer. What is p here? P is 2m plus 1 into p minus 1 is 2m divided by 4 is equal to a positive integer. And we can write this as a 4m square plus 2m divided by 4 must be an integer. Okay. So this quantity is divisible by 4. So this is a multiple of 4. Therefore 4 divide this. And here 4 divide this also. So that therefore m must be of the form 2 into something. So that is, this implies 4 divides 2 into m. And this implies this m must be of this form, that is 2 into n. So that is, this implies p is equal to 2m plus 1. This is equal to 2m. So what is our m here? M is equal to 2 into n. Okay. So that is, this becomes 4m. P equal to 4n plus 1. Okay. So that is here, P is either equal to 4n or P is equal to 4n plus 1. If G is a self-complementary graph, then number of vertices are of this form, either 4n or 4n plus 1. Okay, thank you. I'll stop here.